Okay, today's video is brought to you by the fact that I spent yesterday washing my car in the sun without a shirt, and therefore I got a little sunburn. Anyway, so that means I didn't work outside today on the car itself, and I did some inside work, including the fuel sender settings. We're calibrating the fuel level sender on my wife's 66 Mustang. These are the directions that we're going to be looking at, but we're going to modify from this because, well, watch the video and you'll understand. The sender we're using is from Tanks Inc., and this image is brought to you from their website. Okay, we have a gauge package here, which is the original cluster with Equus gauges for fuel, temperature. These are in the same location as factory. This one sits on the front side, not on the back, behind the gauge cluster like the others do for the miles per hour, and this one is mechanically driven. And then volts, and that's going to be instead of amps, and then temperature. Now, these are slick looking gauges, not just for the way they look in white, but when the lights are on. So check this out. This is so much brighter than the factory, and I bought these aqua colored LEDs from China on eBay. Don't remember the source, but just thought I'd take a chance because I wanted something that wasn't that bright blue that you get with factory gauges being replaced with ice blue LEDs, which is about the only blue color you ever get in the States. But anyways, the point of what I'm showing today is the fuel gauge. So I wired it all up, and this is of course an aftermarket fuel gauge and an aftermarket sender. This sender is the one that came with my Tanks Inc. Setup. I've already measured the distance for a 22-gallon tank, and this is adjustable, and so you have to calibrate it or set it up, and you would expect that the range when this sweeps from being full in this position to being empty, that it would go from 73 to 10 ohms, 73 being at empty and 10 ohms being at full. First, I want to show you what everybody experiences in their car, and that is how the gauge moves corresponding to the actual float in the tank. Okay, this is just a bar to hold its place, and then the float has a plastic thing on the end. But watch the gauge as it goes down, and I calibrated it for full. I'll tell you about that next. Okay, so watch the gauge as it goes down when I smoothly sweep the sender. See how it drops really fast from half to empty? Let me do that again. This time I'll go up, and I'll try to be as smooth as I can. So it went up slowly after about 3/4, because once this is exactly halfway, you would think that's about half the tank, right? Look at the gauge. Which means that that short distance worked half of the sender. And then the rest is going to work from this short distance from here down. And this bend right here in this tang determines how low it goes. So I will tell you right now, I'm going to go back up. I checked the ohm reading with my digital meter. Ancient, but still works nicely. Got to turn the voltage off first, and then you can get it. And this on full was reading about 9 to 9.2, which is, you would think, pretty good compared to what it should be at 10 for full reading. But that gauge needle was a little bit low. Okay, it's still just a hair on the underside, but I bent this tang just a touch down, and it went to about 8.2 to 8.4, and that's what registers as full on the gauge. Depending on the angle that you're looking at it, like if you're sitting and looking at it from the driver's view, okay, you can barely see the full gauge. I'm gonna move you over a little bit more. So you look like this, and yeah, it's close, it's good. Maybe a hair high now, but and that's okay because most car gauges do that. However, when it's at halfway, okay, on the sender, the meter is almost 3/4. So I'm gonna adjust that just a hair. There we go. So I need to think about this, how to manipulate this sender and the gauge, which don't correspond to factory settings anyway. And when it's halfway, as you would imagine it is in a tank, if this was in the center of the tank, because that's what you set up the distance from here to here. Okay, you measure from here to the center of this pivot, and it's supposed to be half the depth of your tank. All right. So at half of a tank, it's telling you still have more, like a lot more range. Okay. So imagine moving the sender a little higher up to where it would correspond more to 3/4 of a tank. Then you have a concern about where the float at the end is, because if the float at this end is at the top of the tank and you're closer to the top of the tank, will it reach the bottom of the tank? It won't. What you're looking at here is a representation of my tank. I used this old English chair that I have with the original leather from England. I brought it home myself when I was there overseas. Never have changed the leather because it has character, and it's still comfortable to sit on. Anyway, this is perfectly 9 inches from the bottom of this representation of my tank. The thickness represents the metal and the gasket of the tank itself, of the cork gasket. Okay, and I had set this according to right here the specs for the tank. So the height from the bottom of the tank to the pivot point is 4.5 plus a hair, I think. No, it's pretty close to 4.5, yeah. And so the center of the bulb is at 4.5, and I figure that's where the fuel, with the weight of the bar and the bulb itself, will be. It might be a little higher than that, who knows, but I'm estimating that it's going to want to sit somewhere around that halfway in the bulb. Now that means that when the bulb is sideways like it is right now, which is probably how I'll install it, that if I wanted to read 3/4 of a tower, actually it's between 1/2 and 3/4. Now I have to reconsider that for my math. So let's say, okay, let me adjust that a little bit. Okay, that's halfway. So let's say that's 65%. Let me figure out the math and I'll get back. So I'm going to move this up a little bit and play with the length of the rod to see if I can get it to represent actual fuel. The back side of my rig, so you can see that the adjustment is available to me from these screws. I hung a composition notebook behind it so it would stay focused better on the subject at hand. And here you can see how it's attached. I've just got one screw holding it to a pegboard, acting as my fuel tank bottom. And then if you needed, you could probably set up boxes to equal the 9-inch height that I have here. So the adjustment now. I reached the maximum of depth at about 3 7/16 to the center of the screw in the bottom of the tank. Okay, so let's play with this and see what I get. This is without changing the length of the rod yet. Let's see what our results are. Well, it doesn't reach full deflection down, but I'm going to have an empty tank at that point. This is the whole point. If it's at the max deflection upward, it doesn't quite reach there. And that max deflection down, it doesn't reach there. So we're going to have to find out what happens. This is obviously less than an empty tank, but this is also less than a full tank. Okay, here are some of my settings as I've established so far for possibly good setup. From the bottom of the tank, we are not quite where the directions would have placed us. We're up about a 1/4 of an inch higher because directions put me at 4 5/8 for a 9-inch deep tank. So we're at 4 3/8 instead of 5/8. And for full deflection, I'm not getting to the bottom of things, but I don't know how this floats yet. So I'm going to test that in a bowl of water in a minute and see just how it floats. Ready for this? You're going to see it at the same time I do. Okay, it's moving around a little bit. So it's not deflecting down all the way. It's really holding it up. And that's good, but that's not so good, except that there's a lot of reserve in the gas tank. So I'm going to check at what depth that is. What does this mean? It's at 7 7/8 from the top of the tank, which is the pegboard, to the level of the water. At 7 7/8, and it's just a hair above empty from where I'm sitting. Actually, it's a little bit where the camera is. It's right on empty. So right on empty, and it's 87.5% of a full tank. Now, we knew that it wasn't going to deflect down to get me the full empty anyways, but that's, you know, I bent this tang a little bit more hoping that it would go down, but that goes way below empty is basically what I'm saying. It allows it to go down further, and then the reading, that's the lowest it'll go. That's using up all, well, and that's still with a 1/4 of an inch to the bottom of the tank. And it'll probably be a little bit more than that. So what does that mean going upward? Well, let me get the water out of here. The sun's in the right place now, reflecting off the floor. So going full deflection upward, it's not quite a full deflection here. And we have less than a full tank. So everything shifted down. I was playing around with the depth. That's why the water's shaking. So I adjusted the lever and turned the ball sideways. Full deflection is possible. It's lower in the tank, and it's definitely below empty on the gauge. At this point, it is, like we said before, 87% of a full tank, or 87% empty. And so that makes sense right there. Put a little black mark right there on the ball as the water level, so now I can measure things like the height for half a tank. I don't need to use the water anymore, and see where it turns out. Okay, so let me place that at half tank, right about there from the driver's position, and it reads at 5 3/8. 5 3/8 calculated to be 60%, 59.7% of the tank used up. In other words, 40% left when the gauge was indicating, oops, I bumped it. right at half. And then will this deflect fully? Yes, it will. It's actually not even touching the board there. But it is fully deflected. And then on the bottom, will it bottom out in the tank? Not quite. Did the height to 4 3/16. I was at 4 3/8. I've got a half tank. And the height of the bulb is looking straight on for half a tank. And at 5 3/16, we have 42% of fuel left. We have used 58%. It's not quite there yet. There was too much of a balancing going on with the length of the rod sticking out, and now it does drop a lot more when it's let go. In fact, I would say that's just about half the bulb or float submerged in the water. And water has more buoyant force than gasoline because gasoline floats on water. So as it turns out, this might sink a little bit more. Now, we are reading almost empty at this point on the gauge. And we're still pretty far from empty. In fact, let's see if the length of this, I adjusted the length by just bottoming out my setting for what I had previously established was exactly a full tank by bending this tang and adjusting it so that it was in contact. At the same time, it was touching the top of the tank. So let's see what it does down. So at full displacement down, it is in the empty reserve zone and not quite touching the bottom. Let me see. So it's 9/16. Okay, so that turns out to be 6%. 6% of the tank left. Now, the gas tank is narrow at the back and deep at the front, nearer to this. So it's really not a full flat tank. And being this low at full displacement, there's that much, half the bulb worth of fuel left, which means that's the reserve. So I'm happy with this particular setting. It gives me the full displacement up. Let's see, half. Let me turn the gauge on, hold on. So if half the bulb is immersed, for half tank reading here, that looks like it's going to be the best setup because that's 46% of fuel left when it's reading a half, and that's excellent. Now, that's not going to change the fact that for a smooth movement, this goes much slower at the top than it does as you get lower. What this all means is that at full, the tank will read full on the gauge and it's calibrated. At half a tank, it'll be 45% of the fuel left, 55% used. And then at empty, there's still going to be, once this is completely at the bottom, not measuring anymore, it will be 6% of 22, whatever that is. It's about a gallon, 1.2 gallons, something like that, I guess. So about 15 more miles after it's below empty here. But if I go by this and set it to empty, looks like it's quite a distance from the bottom of the tank. However, I calculated that to be about 75 driving miles at about 15 miles per gallon. So that means there's a reserve, and you just have to fill up once you get to E, and you'll leave more in the tank than usual once you get to empty. But it's going to have a more accurate amount for when it says from a half a tank, because otherwise, with the depth adjusted, this was not going to leave as much gas from a half a tank down. So the final adjustment vertically, instead of being 4 5/8 inch, turned out to be 4 3/16. Maybe a little touch less than 4 3/16. Okay, and the length of this from the bend, from where it wraps around, it's also 4 3/16, so they equal each other. Smaller numbers than what would have been required by the settings according to the installation instructions. I thought I would test the voltage gauge, and it's reading about 13.2 to 13.5, depending on how you're looking at it, straight on or from a bit of an angle. And let's see what the digital voltmeter says. And it's around 13.5, 13.4, 13.5. Digital voltmeter says 13.4. Now that's what I tested this fuel gauge using. I tried it with some resistors in place, but the resistors didn't last long. They were burning up because I didn't have enough wattage. And I dropped the voltage as low as around 10.7 volts, maybe 11 volts, which is lower than you'll ever see. And the gauge worked exactly the same. So there was no need for the gauge to be on the voltage stabilizing setup for it to work any differently. The only difference that could occur is resistance added from the length of the wire going to the gas tank. So my sender wires were short from here up to the back of the gauge. So this could make a difference in the reading, but I'm happy with the results and really happy that this gauge is reading so well. All these gauges are a 90-degree sweep, but to do that for the oil gauge from Equus, the only way I could do that was to have a mechanical oil gauge, which has the pressure, physically screws to the back right there, instead of an electrical gauge. All the other ones are electrical that have the 90-degree sweep. It looks like it's a little more like 180, but it really is 90 when you look at the direction of the angle from that to the center, and this way from that side to the center. So they're all 90 degree. The alternative was a 270 degree sweep if I did electrical oil pressure gauge. Didn't look the same, didn't look right. Thanks for watching another one of my restoration videos. I hope this helps with some people who may have had some difficulties with their gauge level accuracy. Please like and subscribe, and come back for more restoration videos in the future. Water has more buoyant force pushing it up. It might be down just a touch more, but